So thanks everybody for coming out. First off, I just want to apologize. I've got a ton of like gigantic code blocks here that are going to be impossible to read if you're not super close to the screen. So sucks to suck, I guess. But I'll try and just like highlight the important stuff and make it clear and obvious and easy. This is already live on the internet. I'll just put it up on my GitHub. GitHub hosts your HTML presentations, uses Reveal.js. Cool, so let's go. So make it full screen. So first off, learning Python is fun. Python is a very practical language. You can do a lot in it, but sometimes it's really hard to figure out how to take that next leap forward. So I guess to start, how many people here are 1 or 2 months in or less to learning Python? Okay, so some, not a lot. How many people have used Python in production environments and have production code running? Okay, so like a little over half. All right, so that means there's some middle ground here. The middle ground is who I'm going for. I hope this is useful for you. Everybody else, I'm sorry. Cool, so here's the scenario. I wrote this Python script. It automates something that's really cool that I think is cool. It saves me time. It collects new information I didn't have before. It lets me share reports or insights or, communicate my findings to someone. It does something useful. How do I automate this? How do I say go and run on a schedule and just keep going and don't stop? Don't stop until I tell you to. So I have memes because that's a thing people do, I guess. I don't know, this is weird, but like this is the first one I found. So once you automate things, you get this like feeling like, oh, that's so cool. I got to automate everything, right? But that's a problem if you don't have a good framework to use. So I'm going to go over some different ways you can schedule Python scripts to run. David talked about like the scheduler they have for PySpark. That's going to be way more complicated than pretty much everything here. Also maybe worse, I don't know. So here's what I'm going to talk about. I'm going to talk about cron and the Windows equivalent task scheduler, which is not really equivalent, but I'm going to show you a screenshot. I'm going to talk about the Python module schedule. I'm going to talk about the Python package celery. I'm going to talk about the Python package airflow. And I'm going to go over real quickly cloud environments and how you can do this, AWS Lambda and GCP cloud functions. Those are pretty complicated, not too complicated. And I'm kind of going to breeze past them, but this stuff's online. If you want to read through the details later, that's at your own risk. And then in general, just go pros and cons on everything. So about me, I'm data science at Pangea Money Transfer. We're an international remittance fintech startup here in Chicago. Basically, we have an app that lets you send money from the US to like 15 other countries. And when I say I'm data science, I don't mean I'm a data scientist. I mean I am data science. I'm like the whole everybody. It's like a 40-person company, so I got to do everything. I started learning Python in January 2013, so less than 5 years. Give you an idea of like how my expertise is. I mean, just like a little bit above nothing, but nothing spectacular. I learned Python because I was a data analyst and I was using SQL and Excel, and like eventually like I just got tired of having to do the same thing every single day, every single week. And I was like, I gotta just make the computer do this for me. And Python is really good at that, and it has not failed me yet. So I wrote some example code for this talk. It's a really, really, really simple script. It goes and fetches a URL from this website, free.currencyconverterapi.com. I did it because I work for a currency exchange company, and I don't know, it was interesting. Like, what does this code do right here? It imports some like default packages included with Python, except for requests. You don't need requests. You can use URL-lib if you want. I like requests because it's a little bit easier. Yeah, fetches some JSON data, logs it, returns the data. And then I format it. I break out this nested JSON into just a flat thing that I can stick in a database. That's all this part does. I use ordered dict only because I want the JSON to be in the exact same order every time when I insert into my SQLite database. I have a function to create the table if it doesn't exist, which usually should exist. I have a function to save it to the database. And then I have this function run job, which says, hey, go do all those other functions I ran before. And log it and stuff like that. So it's nothing complicated. It's something like you might do on a side project, something you might do maybe on like a little minute task you have at work. It's something you might not be doing, but you want to learn how to get there. So took a screenshot of like what happens when I run this. I called it my cool script because it's cool. Connects to the DB, establishes the DB table, gets the data for US dollars to Mexican pesos. It tells me it worked. It formats it, tells me it formatted it, tells me that it inserted that formatted data into the database, previews what that row would look like, and says, job done. Cool, good job, script. So, okay, now I want this to run every hour. Introducing cron. What is cron? Cron is built into Unix systems, so this includes Mac, includes Linux, BSD. I don't know what else Unix systems you would use, but other Unix systems. It's a job scheduler. It runs in the background and it looks for things that you've told it to schedule, and it schedules them. It also schedules things for your operating system that you might not even be aware of. Usually you don't interact with cron directly. You interact with this thing called cron tab, which means cron plus table. It's just a config file. You give it a weird syntax to say when it should run, and you give it a command of what it should run. I put this note because you can totally use cron and cron tab on Mac, but Mac is like weird about it, and they want you to use this thing called launchd, which uses XML as its config and has separate jobs for everything. Yeah, have fun with that. Cool, so here it's me in my terminal saying, how do I use this cron tab thing? So first of all, I just said, what operating system I am. I'm on Ubuntu 16. I know 18 is out. I haven't upgraded because I'm lazy. The function which, if you guys don't know, tells you where things are installed. So I say which cron tab, and it says, oh, cron tab's in user/bin. I did cron tab -h, thinking that that would give me help. It does not, but it does give me what it can do. And you can see you can edit a user's cron tab, you can list a user's cron tab, you can delete a user's cron tab, and you can prompt before deleting it. Do that if you're going to do that. I'm going to edit it. This will open it in your default like terminal editor. If you don't have that set up, it might be Nano, it might be Vim. I don't know. One thing I want to point out here, everything here says it's the user's cron tab. What does that mean? Well, since I just said cron tab, it's going to make one just for my user. So like I am like home/Ray, or on Mac it would be like user/Ray. Well, if you're on like a remote server with other users logged in, they're going to have their own cron tab. So potentially one of the downsides that I'm going to get to here in a second. So this is what the cron tab looks like. Gives you this awesome introduction of like, here's what this thing is, here's how it works. Read this on your own time. At the bottom, I'm going to show you like, so it has this thing that tells you how those things are structured. It says minute, hour, dom, mon, DAO, command. Super clear, right? So here I've got */15, 9-17, ***, user bin Python, my cool script.py. What does that do? Well, the syntax is super weird. I don't know. I Googled it. What do I get when I Google it? I get crontab.guru, type that in. At every 15th minute, past the hour, from 9 through 17, which means run this every hour I'm at work. Make it look like I'm doing stuff. Cool. So, pros and cons. One, cron is not Python. Why am I even telling you guys about this? Well, for one, it's like if you Google like how do I automate something in Python, if you read a book like automate the boring stuff, it's going to tell you to use cron, right? It's just the default that everybody uses. It's probably the easiest way to start off. It's actually like, it works really well. It has its downsides, but it does its job really good. It checks every second for things to do, and if it finds something to do at the time you set it, it does it. The downsides, that syntax we said, */15, 9-17, not super human friendly. You have to be on a Unix system. You can't do this on Windows. I don't think you can do it. Maybe you can do it on like the Windows Linux subsystem. I'm not going to bother trying with that. It's hard because everything is user-based, it's hard to get your environment variables right. It's hard to get your like local user programs and files right. A lot of times companies will do it and everybody does sudo cron tab and they all install the root, and then you got your problems with that too. Lastly, like if your cron tab doesn't run or it errors out, it's on you. It's on you to monitor it. It's on you to check your logs for errors. So that's kind of the downside and why we're going to look at other options. This is a screenshot of the Windows task scheduler. This does not at all look like a terminal. It's a thing that gives some buttons where you can create tasks and type in things of how it works. I've used this like 5 years ago, and I'm not going to swear, so I'm not going to talk about it. Cool, so moving on, Python module schedule. It's from, I think, Dan Bader. He like runs like Real Python or some like popular Python blog. It is cron, but it has a much more Pythonic syntax. So it's human friendly. That's the idea. It's the primary API concern for it. Here's some sample code. I take that script I have. I say import schedule, import time. From that script I wrote, import my main job. From there I can say schedule, every hour do run job. And every hour it will run my job. All I got to do is have this while true loop. I know like the blue highlight on the blue background is impossible. I didn't realize that till last night. I don't know. Sorry. It looks better than the alternative, so I'll give you that. One thing I want to point out here real quick too, like, well, this looks super easy. I did this thing at the bottom, time.sleep, 3600. Well, doesn't that mean it's going to wait an hour, 3600 seconds, and then do it again? Why do I need this schedule? Another way you can schedule things in Python, you can just use time.sleep. That's also pretty scary to do. You should probably not do these two things together. You shouldn't tell schedule to run every hour and then sleep for an hour, because it's going to wake up and be like, oh, I don't remember what happened. So you probably should want to make it sleep for maybe like 1 second or a minute or maybe 5 minutes, like something short enough that it will pick up and check and say, okay, I'm still good, I can go back to sleep. So pros, it's Python, it's Pythonic. It's way easier to figure out how to schedule things in like a human-friendly way. You can say like, do it this week or next week or on this day of the week. It's super easy to just, if you already have your script, leave it alone and just import it and run it on that schedule in another script. And it's more straightforward than just using time.sleep by itself, right? What are the downsides? Well, just like cron, it doesn't tell you your job failed. It doesn't tell you that your job didn't work the way it was supposed to. It doesn't do logging, doesn't do monitoring. Those things are up to you still. Lastly, like running like my schedule thing, if I just said Python my schedule, that'll run. But what if I log out or there's power failure or any of that other stuff? What if my shell goes, crash? It's gonna die, right? So it's probably best to actually wrap this in another tool like NoHup or tmux or something that'll like virtualize your Python runtime. I'm not gonna talk about that stuff. You guys can Google it. So moving on, Celery. This is where things get weird. Because Celery, what does that have to do with scheduling? I thought Celery was a task queue. Celery is a task queue. What is a task queue? I made this in ASCII art. Guess me how long it took me to do this. Way too long. So Celery like sits in the middle. It's the queue in the middle, right? You write Python that says do some amount of work. When I'm ready for it, send that work over to the queue. The queue says, okay, thank you. I'm going to hold on to this until somebody tells me I'm going to go work on this. You have workers. You can have 1 worker. You can have 5 workers. You can have 1 million workers. That's up to you. Celery doesn't care. The workers, all they do is they pull the queue and say, hey, do you have any more work for me to do? No? All right, I'll hang out for a while. You have work for me to do? Cool, let me go take that work and do something with it. So for our schedule, we're going to send this job to the queue. Our 1 worker is going to monitor this queue, see, oh, you have something for me to do, and it's going to write it to a log, or write it to the SQLite database, or do whatever you want to. So what do you need to run Celery? You need something to run Celery. What does that mean? They call it a broker. It means you have to have something else coordinate it. So Celery is kind of the code to handle the logic, but you need another server. You need another application that actually handles receiving and notifying and sending things off. These are the three most popular things people use. Redis. Redis gets used for a lot of different stuff. It's not just for being a queue. It's actually probably not usually being for a queue. But now that you have Redis streams, it's really good at this. RabbitMQ is probably the easiest message queue to use, but it's harder to install, so I like Redis better. And then AWS has this like simple queue service that literally does nothing except for take something, send it off somewhere. That's all it does. So, using Redis, well, I don't want to install Redis, so I'm going to use it running Docker. Here's how I run it using Docker. 2 lines, Docker pull Redis, Docker run Redis. I gave it a name so I'm not confused by it. I said run as a daemon, meaning run in the background. And I said what port to expose. That's all I did. It's not hard. Now I got Redis installed and running. Good reason to learn Docker, by the way. Install applications in 2 lines and have them up and running. And then you can just kill them or delete them and they go away and it's super easy. Cool, so how do we use Celery? I say from Celery, import Celery. Well, Celery comes with a cron tab. It comes with a schedule, which means I can say from celery.schedules, import cron tab. Well, now I have the ability to schedule things on like this cron-like syntax, this schedule-like syntax that we introduced before. So you instantiate an app. That app, you give it a name. I called mine tasks. And I said the broker that's going to handle running those tasks is Redis. And then all I do is I set up this one function that says set up periodic tasks. I set it up with this decorator for Celery that says once it connects to the broker, here's the configuration you're going to do. So you only need to do this once. After this, you can just go to town adding new tasks for it, adding new schedules, new jobs to run. Cool, so I gave 2 examples. This one is in like commented out. This one is not, because I wanted to show how you can do multiple options and how you schedule it. First one says every 3,600 seconds, every hour, right? And I gave the name, run my job every hour. The other one I said, use this cron tab syntax. So I said cron tab, the hours are 9 to 17. Those are the hours I want you to run this job. Minute, I use the same syntax I used before, */15. What this does is it converts that to the cron-like syntax that the computers know and love. It runs the job. This .s thing just means do it in Celery. And I gave it the name, run my job every 15 minutes between 9 and 5 p.m. At the bottom, it's cut off a little bit, but it says run job. I didn't put the rest of it because you guys saw in my code that ran a job earlier, right? That's all you got to do. You decorate your main job to run with an app.task. This configuration is going to say when you want to run things, and it's going to find this job, and that job is going to send it over to this coordinator. Okay, so that's cool, but like, what if I want to run this script on multiple different inputs? Instead of just running one currency, I want to do like 1 million of them. I want to check all the currencies. I want to do some arbitrage. How do I do that? Well, an easy way to do that, first, here's my old code. Just to remind you what it looks like. It's ugly, don't pay too much attention. Here's my new code. I did that thing that we did before. And I added a new function up top that says retrieve currency rates. And what it does is it opens a CSV, splits those CSV into a Python list, and it says for currency and currencies, pair and pairs, run this job. Notice this time I didn't say job.s. I said run job.apply async pair. What that means is it can run all of the currencies I want to go scrape at the exact same time. It'll say, oh, here's one, send it over, or here's one, send it over. It'll just send them all over. So if you've got multiple workers, every worker is going to go look for a task. If it finds it, it's going to run it, which means I'm now parallelizing this code automatically. Pretty cool. The rest of it, this app.task, exactly the same thing. I just added an input parameter, input argument. I said, take a name instead of always doing Mexico. And then when I get the currency data, it's going to pull the data from the parameter we throw in. So pros of Celery. It's still Python. It can do simple syntaxes, and it can do pretty advanced syntaxes. It's easier to scale up because it allows you to do things asynchronously, allows you to run code in parallel. It works best if you keep everything composed of like really small tasks, really small functions. You can kind of compile these too. You can say like, this task is going to do this something, which is going to take the output and do something then, and keep going down the chain. Yeah, so I think like you get a big trade-off here, right? You introduce a whole lot of extra complexity. You have to learn what decorators are. Like if you're new to Python, you might be like, why am I at anything over my function? Don't worry, it just means I'm going to wrap that function in another function behind the scenes. It requires another application to run. It requires a broker like Redis or RabbitMQ or another messaging queue behind the scenes, which means you got to maintain that server or maintain that application. It's more work, it's more maintenance, but it allows you to do a lot more complex operations. Cool. So one thing I didn't talk about, like, what if your job fails? What if your job doesn't run? Well, Celery has this cool thing called signals. Signals are kind of like the if this, then that for Celery. There's a whole bunch of them. Like, they're linked if you want to go check them out here. But you can say, like, run this thing before the task starts. Say, hey, your task is about to start. Run this thing when the task ends, saying, hey, your thing ended. And that can be like an email, can be like a post this to Slack, send me a text message, like call my mom and tell her I'm okay, whatever you like want it to be. It can also be like, hey, this had an error. That error doesn't have to be like just logging. It also be like, well, try this other thing instead. Try and run the function again. So you can get pretty complicated. Well, no, you can get pretty complex, not complicated. Next on the docket, we got Apache Airflow. This is a tool that got built out by the team at Airbnb, I think. That's why it's Airflow. Yeah, I think that's right. They donated it to Apache. It's still in the incubator stage, but it's on like version 1.8, if that means anything to you. So what is Airflow? Airflow is a platform to programmatically author, schedule, and monitor workflows. What does that mean? It means it's a really fancy cron job. Cool. One thing that's really cool about Airflow is it's very explicit that like what you're doing when you build these tasks is you're making a directed acyclic graph, which if you studied algorithms and data structures, you know what that is. If you don't know what that is, Google it. It's a like good opportunity to learn more. I'm not really going to take the time to explain it. I'm going to show you a picture which shows some, and you'll get the idea. When you structure your code in these DAGs, it lets you kind of create like Lego blocks. So you can have like your base layer, and then you can add like on that base layer, do these other things. It lets you build out complexity one step at a time, which is really nice. The Airflow scheduler will also automatically split up your workload. So if I say, well, I'll give you an example, like in the code here in a second, but it lets you like parallelize for free. And in addition, you get this really cool like web UI that shows you like all the jobs you've got going on. Let's just show you guys it. This is the web UI. It's a cool GIF. It's going to show you all the different stuff it can do. You can see from the metadata database like what's been running. You can query it. You can read the code straight up that's going in there. It tells you how long things run. It tells you if they were successful or not. That's a DAG. This is a really complicated one. I don't advise you guys to build things like that unless you absolutely have to. I don't know how to stop this GIF, so I'm going to wait for it again. But you can kind of see that you got these things that point arrows at other things which depend on other things. Directed acyclic graph. Cool. So that web UI doesn't look like Python, but Airflow is still just a Python script. Say from Airflow import DAG. From Airflow import these operators. There's like a bash operator, there's a Python operator, there's like a Hive query operator, a MySQL operator, there's a bunch of operators. Because it's open source project, there's community built operators. Go check it out. They probably have something for what you want. If they don't, you can build it, contribute to open source. What do you need to do? Well, I just imported my code. I did not like paste it in here. You can do that if you want. I don't advise you to do that. You give it some default arguments. So you say, well, who owns this task? Who owns this DAG? Does it depend on the past? What does that say? It says, I don't know, false, I think, but it's blue, so I can't read it. Sorry about that. You give it a date to start, which means you can put it way in the past, and when you kick this off, it'll go and backfill all of those dates. Or you can give it a date like today and say, don't worry about the history, just do from now forward. You give it an email. This implies that you have an email server and email credentials, like environment variables set up. That's a challenge. Good luck with that. You can tell it how many retries to do every time. So default, I think, is 1. I set this one to say, if it fails, try again 4 more times. And you can say this retry delay, like how long should it wait before trying again? I set it to 5 minutes. So some nice kind of error handling, error notification stuff built into it right up front. How do you build your DAG? You say DAG equals DAG, give it a name, tell it what the default arguments are. Those are these things. And then you give it an interval. This is the same thing that we were doing before, right? I can say run every 3,600 seconds, run every 15 minutes from 9 to 5 p.m. But they also introduced these nice little wrappers like hourly, daily, weekly. There's about 20 of them. Go check out their webpage. By the way, like all of these like things here are links to it. So if you guys go look up my presentation online, like all of the info and documentation is just linked to it. There's tons of tutorials linked in here as well if I don't do a good job explaining. Cool, so this is basically like how you can run a job in Airflow. Here I just said I'm gonna make the one run job DAG, and it's just gonna call my run job function from my cool script that I imported. That's all it's gonna do. Just like Celery, if we wanna parse that and handle multiple things at the same time, I can do the same kind of thing. I can say open my CSV. For each thing in the CSV, this is where it gets interesting. I'm gonna create a new function that I'm gonna call run job task, and it's create a new task for the DAG. I'm gonna give it a unique task ID that's just gonna be whatever the input parameter is. So for every currency that I add to my list, it's gonna create a task for that currency, and it's gonna run it. It's gonna run it on my function. Cool, so what does this mean? This means like, I now automatically ran that whole CSV at the same time, at the same schedule, in parallel on my computer. That's pretty cool. What you can also do is explicitly declare these as like upstream tasks. I thought I had that on here, I guess I don't. But what that means is you say, this task I made, run job task, dot upstream task, and that method says, don't run this unless the previously thing ran and executed successfully. So you can kind of build these functions that run after other functions complete. Cool, so pros is it's Python, kind of, mostly. I mean, I don't know how much this really feels like Python when you're calling Python operator and it calls a Python function, but it's kind of Python. Super easy to get started, like scheduling things. Has that awesome web UI that I had the GIF up of. It's really easy to scale up your automation to multiple scripts, multiple jobs, dependent jobs. And also what's really cool is like if you're using Google Cloud, they have this as a managed service. So you don't need to install it, figure out how it works. You just say, go, run, and then you throw your code in there, which is really nice if you've ever had to like manage an Airflow system. Downsides, you have to have a database for it. It'll do this for you by default. It'll install local MySQL to handle the metadata. That GIF showed like how you can query it to see when things ran. You don't ever need to do that, but it's there. You can also set that to be like an AWS RDS instance or your own different database on your premise server. That also means you have to manage that database and make sure that it's up and running for Airflow to run. You have to make sure that the server Airflow is running unless you use Google Cloud. And you have to figure out how these DAGs work and what that means and what dependencies are, and yeah. So it's a pretty big leap up, but the benefit is like really this line here. It's like the ability to scale jobs up and handle complexity in a kind of elegant fashion. So sure, it's a learning curve, but I think in the long run, like the more difficult work you're doing, the better it is for you. Cool, so real quick, I'm gonna go over like the cloud offerings and how hilarious they are. So AWS Lambda, what is the Lambda? It is a function. Lambda is functions as a service. Essentially, It sticks your code in a little Docker container and tells it to either accept HTTP requests or run on a schedule like a cron job. I'm going to show you guys the cron job one, but it really works well for both of them. The coolest part about this is like you don't manage the server. You're not worried about setting up the computer. You're just saying like, I don't really give a poop about like, you know, that stuff. Just go and run my stupid script when I want you to run it. That's awesome. We call that whole idea like serverless. Downside is it can only run for 15 minutes at a time, and it can only have like half a gig of disk space, so it's kind of got to be small tasks. You can use some other AWS services to get the same features that eliminate those cons, but they introduce new cons by having to introduce like more complexity of like setting up and administering this stuff. Fargate is actually kind of like a simpler version of ECS. I'm not going to talk about those. So how do I adjust my code so that it works on AWS Lambda? I create a function called Lambda handler, and I put my run job in there. Done. Super easy to adjust like getting my function before onto the schedule. Cool. So what is a handler function? Well, to start off, that name, Lambda handler, I like that because it's very explicit. This serves to handle the Lambda functions, and that's it, nothing else. So you can name it whatever you want, but boring names are good for a reason. It has two parameters, event and context. They're kind of meaningless for these cron jobs. They are about like passing parameters into it and then having like network context and logging and runtime context. That's really useful for like REST APIs, not so useful for our crons. Also, so like that code I introduced in the beginning, I have all these like standard logging stuff. That'll work, but you probably want to make it like JSON friendly for Cloudwatch. I'll talk about Cloudwatch more in detail because it's kind of like a hilarious thing that AWS does, but it's super useful. And you can't use SQLite in a Lambda database because it's local to that container, so you should probably switch where you're writing your database to something remote, either a remote database, or I would just use S3 for basically everything because it's like your cloud file storage. How do you deploy a Python script to AWS Lambda? You just follow these easy 6 steps. Yeah, not so easy actually. Essentially what you do is you take all of the like pip install things on your computer, the actual installs, the binaries for them, and you take your code and you wrap it up in a zip file and you upload that to Amazon. You can either upload it to S3, you can upload it directly to the Lambda service. But that's basically what you're doing. I have like detailed instructions on how to do that. I'm not gonna like read this off, you guys can read. And I'm gonna show you how to do it on the CLI. You can use like the AWS CLI and say AWS Lambda create function, throw in this stuff where you want it to be, what you want it to be the name of, where your zip file is, what the role is. You have to tell it what the handler is. So that's why I use Lambda handler, so I can remember what it is. You tell it what your runtime is. We're Python 3.6, because that's, well, it's not the newest Python, but it's the Python I would use, because that's what AWS has. You give it a timeout. This timeout can go up to 900. That's 15 minutes. I set mine for 300 because I want to give it some failover in case Lambda takes some time to start up or whatever. And you give it your memory size, like how much gigs of memory do you want your service to have. The more memory you use, the more it costs. But it's really cheap, as we'll see. So what happens when you do that AWS CLI call, or you do the step-by-step instructions in the console? You get here. You say, oh, this is my function. This is what it looks like. Well, it shows you this like blue highlight, Cloudwatch event, and it says configuration required. You mean I created that function and I still got to do more stuff? Yeah. So you go to Cloudwatch, you say Cloudwatch this function, and it says configure triggers. Triggers can either be HTTP request or they can be a cron. We say that's like event pattern or schedule expression. That's HTTP request or cron. So I picked schedule, and I said my schedule is rate 5 minutes. I didn't say this, I just stole this screenshot from the internet. Well, it's the same thing. Right below it, it actually tells you how you can do it. You can say rate 1 day, cron 017 question mark star mon through fry. So AWS has like pretty good documentation about all the different ways you can syntax that schedule. Cool. So more links to documentation, alternative ways to deploy. Why do I cover this? Because those 6 easy steps are kind of weird, kind of a hassle. These first two, run using this Docker pattern. The reason you do that is because you can test your functions locally instead of just deploying them to AWS and saying, I hope they work, let me go try it. AWS SAM is their serverless architecture management, something like that. And then there's serverless. Serverless is kind of like the cross-cloud open source framework of choice. I really recommend this if you don't know what to pick or you want to try this but don't know where to start, because once you have your code in their serverless framework, you just say serverless deploy and you're done. Like, that's freaking awesome. No more zipping up binaries and garbage. Cool. So pros, it has built-in monitoring and logging through Cloudwatch. You don't have to worry about that. Because they tie those two services together, they take care of that stuff for you. So every time it runs, you get detailed logs of what happened. It gives you like this graph that says how many times it was invoked, all that stuff. You don't deal with infrastructure management. Like, you're not keeping a virtual server running. You're not trying to upgrade your version of Linux or patch security holes or any of the IT stuff. You just, I don't know, Amazon does it for me. And it's dirt cheap. So how dirt cheap is it? You get 1 million free requests per month, kind of. That's on a free tier at like the very minimalist thing. So the configuration that I did, I said run for 5 minutes and use 0.5 megabyte of memory. Well, that runs 2,600 times a month for free. That means I can have 3 of my hourly cron jobs for free, plus 0.5 left over. Also, like, how hard was it to adapt my code to run on Lambda? I just said function Lambda handler and run my job, so super easy. Cons, you have to have AWS account set up. You have to deal with like security and permissions and roles and all of the IAM stuff. And if you do that for a living, if you're like a DevOps person, my hat's off to you. But hopefully that stuff's just figured out for your developers. It has that 15-minute runtime limit, has a limit on disk space that you can do too, so not meant for big data. It's not meant for Spark. GCP Cloud Functions, super, super quick. Not going to spend any much time on this. They're kind of the same thing as AWS Lambda, except for GCP is way easier to use, in my opinion, from experience. Has limited offerings, relatively different offerings. It does have Airflow, except for in this case, because GCP Cloud Functions don't have a schedule. So I wanted to point this out, because a lot of people think like, oh, I can just, if I can do that in Lambda, I can do it in Google Cloud. You actually can't. They don't allow that. So you have to go through this crazy process where you, I don't know, I'll just show you the picture. It's easier. So you like have an app engine. That app engine has a cron that comes with it. You publish to a message queue, and then that message queue publishes to your functions. Like, that's stupid. They should just create a schedule. I asked them to do it every month. Cool, so why did I even bother telling you about GCP Cloud Functions? Because the support for Python is really, really cool, and I want to push that out there. Like, you literally just, I'm just pictures. Pictures will make this better, right? Oh, that's so small. That's still so small. Okay, well, you can't see this, but it says, give it a name, function. How much memory do you want it to have? What's your trigger? Your trigger either HTTP or like 6 things from like Firebase or Google Pub Sub. So kind of HTTP is your only like real choice unless you're on those other things. How do you want to get your code in there? It has a built-in code editor. You just paste your code right there. Cool, so this is an example, like I pasted my code in there and what happened? Well, I had to do it 4 times for it to work, but it worked, right? Automatically, every time I saved it, I get a new version. That's super cool. You can set up this test where you say, I want to test for these things, what happens on the output, shows you your logs for what it stepped through, what the output was. Yeah. So I think this is a lot easier, more friendly way for people to get started with cloud than the AWS stuff. Cool, so that's kind of the bulk of my talk. I have this quick decision matrix for like reference. It's kind of garbage, don't really refer to it. Like, do your research, like look at all the links I provided. But I think like if you're on AWS and you're doing small data, like Lambda's pretty awesome. It's what we use for most of our cron jobs at Pangea. For medium data, things that don't run in 15 minutes or don't fit in half a gig of disk space, we use ECS, Elastic Container Services. Basically what that means is I spun up a container that has more memory and more hard drive space, and I run my cron on that. Not really too different. Glue is also a way you can schedule things on AWS. Glue is a managed PySpark service. So if you like that last talk and you want to get started on PySpark, but you don't want to install PySpark locally, AWS has this thing that you can just dump into automatically. It does have some setup required for permissions and things. If you're on GCP, like basically that means you're on premise for like small medium data, like you're just building a virtual server and you're creating cron jobs or using Celery maybe. Unless you want to do like those complicated ETL DAGs that we talked about, then you got Composer, which is Airflow but managed. Cool, so just to conclude, wrap up, summarize, Python is awesome. There's a lot of cool tooling available for scheduling jobs in Python, automating stuff, and everything I talked about is super documented everywhere in the world. There's like 50 million articles for all of these things. Some of them are linked here. And then there's some other stuff that is possible you can do in Python that I didn't go over, in case you want to review that. That's my fancy talk.